What's up, people? Today we're going to continue our talk on exponential functions. We're going to start by talking about the natural base e. E is known as Euler's number. Some people say Euler's, but it's Euler's. E is approximately this great big number here, 2.718281827, yada yada. And the reason we got the yada yada is because it is an irrational number. Remember, that's a number that's a decimal and it never ends and it never repeats. It's also a transcendental number, and what that is a complex number that can't be the root of a non-zero polynomial equation that has coefficients that are integers. E is also the base of natural logarithms, which we'll talk about before long. So if you see the natural log of x, that's the same thing as the log base e of x. And what we're mostly interested in is E is used to calculate continuous compound interest. So since E is an exponential function, the graph doesn't look very different than the ones we talked about before. I'm just going to do a quick little yoop. So again, it has a y-intercept of 1. If you go over here 1, it goes up to about 2.71. You know, looks like your generic exponential function. The x-axis is an asymptote, all that good stuff. And that's if you graph f of x equals e to the x. Okay, looks like that, basically. All right, let's learn a little bit more stuff here. So we're going to talk about money, which is most people's topic of interest. So we have a couple formulas you need to be familiar with. The first one is the regular compound interest formula, and it's A equals P times 1 plus R over N to the NT. So let's talk about what each one of these letters represents. A is the account balance. All right, and P is your principal. That's the amount I start with, or the original amount of my loan. R is the rate, and just like we did before, you want to change that to a decimal if it's a percent. All right. N, and both of these N's are going to be the exact same thing. N represents the number of times it compounds per year. And we'll talk more about that in a second. And then T is just your time in years. All right, so let's talk just a little more about N. Some words that are very common in these types of problems are semi-annually. All right, when you see semi-annually, that means twice a year, so that would mean that we use N equals 2. Monthly. That would mean we need to use N equals 12 because there's 12 months in a year. Bi-monthly. So it happens every 2 months. So in a year that would happen 6 times. And quarterly. Which means 4 times a year. Every 3 months, quarterly. All right, the next formula is for continuously compounding interest. That means the interest doesn't compound twice a year or once a month. It's continuously compounding upon itself. So this formula has our E in it, and the letters mean the exact same thing. A stands for your account balance. P is your principal or your starting amount. R is your rate. Still need to change it to a decimal. And T is your time in years. So let's do some examples. We'll start with a couple of easy ones that we'll just need our calculator for. It says the population of a small Polynesian island can be modeled by f of x equals 8 times e raised to the 0.8x. How many people originally went to this island? So originally would mean in the beginning, no time has passed, so they want me to find f of 0. So that would be 8 times e to 0.8 times 0. Now I could throw this in my calculator, but let's use our noodle. 0.8 times 0 is 0. Anything raised to the 0 equals 1. And 8 times 1 is 8. So in the beginning, 8 people, that was it. The next question says, how many people will be living on the island 10 years later? So for this, we're just going to find f of 10. And I'm going to use the calculator for this. So that'll be 8 times e to the 0.8 times 10. All right, so let's get out our calculator. Turn it on. 8, all right, and then e is right here. You have to do shift and the natural log button. And then 0.8 times 10 and hit enter. And wow, look at how big that got so quick. So that was approximately 23,847.6639. Let's for goodness sake round to the nearest whole person. So that would be 23,848 people. Just in 10 years from 8 to 23,848. That's a lot of growth. All right, let's do some problems with money, honey. It says, find the accumulated value of an investment of $1,500 for 2 years at an interest rate of 3.2% if, and then we got to do different ones. So it says compounded semi-annually. Well, we know that that means that n equals 2, and we're just going to plug these numbers they give us into the formula. So this 15,000 would be my principal, the 2 would be my time, and the 3.2% would be my rate, but I'm going to change that by moving the decimal. Whoop, whoop. So that would be 0.032. So we have A equals, and we're definitely going to use a calculator for this, 15,000 times 1 plus 0.032 divided by 2 raised to the 2 times 2. All right, so put in 15,000 for P, R, my rate, 0.032, my N is 2, so I'll write that in both places, and the time is 2. So let's put this in the calculator. Clear that out. 1 plus 0.032 divided by 2. And you could simplify that before you did this if you wanted to. Raised to the, let's just go ahead, and 2 times 2 is 4. We can make that leap. All right, and we get approximately, I'm going to round to the hundreds place because we're talking about money. So we'll go to the penny. And we have $15,983.20. The 8 will look at the 6 and round up, 29 cents. So in 2 years, I went from $15,000 to $15,983.29. How's that sound? All right, let's look at the next one now. For the next one, the interest is compounding quarterly. So we know that instead of twice a year, this means they're paying me interest 4 times a year. So let's plug this into the formula. So A, so exactly the same. The only difference is N is now 4. So 15,000 times 1 plus 0.032 divided by 4 raised to the 4 times 2 for the 2 years. And again, I'm going to put this in my handy dandy calculator. So 15,000 times 1 plus 0.032 divided by 4 to the, and then 4 times 2 is 8. And we get, again, rounding to the hundredths place, 15,000 $987. That one will look at the 4 and say the same, and 31 cents. So if we go from semi-annually to quarterly, it makes a whopping approximately $4 difference. So not that big of a deal. Not for $15,000 investment anyway. All right, and then let's look at compounded continuously. So this will be the formula with our E in it. A equals P times E to the RT. Gonna plug in these same values. P is 15,000. E, the rate is 0.032, and then the time is 2 years. Again, gonna plug that into the calculator. So 15,000, whoa, times, I don't really need that times, let's just put in our E. Let's try again, 15,000 E to the 0.032 times 2, pachow, and we get approximately $15,991.30. That 8 will look at the 5, it'll bump it up to a 9, 39 cents. So it went up another $4 basically. All right, so that's it for exponential functions, and I hope you have a fabulous day.